Matter is all around us. Matter is around us when we're at home. Matter is all around us when we're outside. Our bodies are made up of matter. So yes, that means that you matter. That's this week with Adventures with Miss Bizzle. So here are your vocabulary words that we're going to be using for this lesson and throughout the States of Matter unit. So the first word that we're going to discuss is the word matter. M-A-T-T-E-R is the word matter. Matter is everything around you. Everything. Matter is anything that takes up space. My lab jacket that I have on, my earrings, this board that I'm writing on, my globe back here, the air that I'm breathing, the water that I drink, everything that's around you is matter. Now, of course, matter is not the same. It's not the same at all. It doesn't look the same. It doesn't sound the same. None of that. But there are some words that we can use to describe matter. And the way we describe matter is by its property. So let me erase this word. And the next word is property. R-T-Y. So property, when you hear that word, you may think, oh, that's something that belongs to someone. Well, not exactly in science. In science, a property is a word that describes matter. Just like in ELA, you've learned that adjectives describe nouns. Well, property does the same thing. It describes matter. For example, let's take this candle here. Let's think of some properties that would describe this candle. Now, also, I want to remind you, when you're thinking of properties, use your 5 senses, okay? Taste, smell, touch, hearing, and seeing. All of those 5 senses. Use those to describe matter, okay? When you think of your properties. So let's start with taste. We can't eat a candle, so we can't list any properties for tasting. Smell. Let's smell it. Oh, it smells so good. This is actually one of my favorite candles. It smells great. So one of the properties of this candle is that it tastes. Tastes like it smells like peaches. So that's a property of this candle. If we feel it, we see that it's hard. So that's a property of this candle. If we you can't hear anything out of it, it doesn't make a sound. So we can't list anything for hearing. And for sight, for what we see that it's white. So, or kind of an off-white color. And that describes this. So that would be a property of this candle. So as you see how I use my senses to describe everything that I see and hear and can't taste and can't can't hear and can't taste anything, but I'm describing what I can feel, what I can smell, and that's it. What I'm smelling, what I see, and what I feel. So that's how you use your 5 senses to describe matter and to figure out the properties of matter. Okay, let's move on. All right, so our next word. So I want to introduce you to 2 words that you could use as properties of matter. The first word is this word you may have heard of. It's transparent. Okay? Transparent. That word transparent means it's completely see-through. You can see right through it. For example, my science goggles here. You can see right through these. I can see through it. So these are transparent. You can see right through it. Same as this water bottle. See right through it. You see me? These are transparent. Okay? Now, the opposite of this, I'm just going to take off carrot and I'm going to replace that with lucent. Translucent. Translucent means that you cannot see through it at all. Like the candle. I can't see through it at all. Probably this top part, yeah, but the candle itself, I can't see through it at all. Same with this little cup here. I can't see through it. It's translucent. Same as my glasses case here. I don't see anybody. It's translucent. All right. So those are two words that you could use as properties that could describe matter. All right. Let's move on to the next word. Let's go to this word, molecules. Molecules. Okay. Molecules, those are the tiny, teeny, tiny building blocks that make up matter. Okay, we can't see those with our own eyes. We'll have to get a microscope. But everything that's around us, all matter has different molecules inside of them. And those molecules help you to determine what type of matter it is. For example, let's go to the next word. Let's go to the word solid. So matter can be a solid. That's when the molecules inside of solids are really close together because solids have their own shape. So the molecules have to be really close together so that the solid can keep its own shape. Like my marker here that I was writing with. The molecules inside of this are really close together. It has its own shape. And because it has its own shape, it will not take the shape of a container. Let's try this little sticker here. I have my Georgia voting sticker here. Yes, I voted. If I was to try to put this inside of a bottle, I'm putting it inside the bottle. Did that sticker take the shape of the container? Did it take the shape of the bottle? Nope, it didn't. It kept its own shape. Even, I know I folded it and put it in, but still, it has its own shape. It does not take the shape of its container. So that's what a solid is. And now some people may think that all solids are hard. No, solids can be soft. Anything that has its own shape is a solid. For example, this little bracelet here this is one of my daughter's bracelets, but it's really soft. It's really soft and it's stretchy and it has its own shape. And if I was to put it inside of a container, it would not take the shape of this container. So I don't want you to think that all solids have to be hard. No, some solids can be soft. But as long as it has its own shape, then it is a solid. All right? So a solid is a type of matter. Let's go to another type of matter. Let's go to liquid. 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 Liquids are the molecules inside of liquids are close together but not tight together like they are in the solids. In solids, they're really close together because they have to take their shape. But in a liquid, they're just near each other, okay? Because liquids flow, okay? They flow. So, for example, I have my big water jug here. Whew. This water jug, this is what I drink every day. I drink all this water every day. But as you see the water in here is taking the shape of the container. That's what liquids do. Liquids do take the shape of its container, okay? If I was to turn it sideways, you see the water is going to be the shape of the container. All right. Oh, I'm going to put that down. That's so heavy. All right, so I have this little cup here. It actually has some water in it. You can't really see. You may see it a little bit if I shake it. Nah, can't see it. But this water in here is taking the shape of this cup. Now, if I was to pour it into another container, then it will take the shape of that container. Now, my little sticker is still in here, but it's going to have to get wet. So if I was to pour this water into this bottle, now that water is taking the shape of this container, of this bottle now. Okay. And as we see, our sticker is a solid, it's still a solid, it's staying tight. It is not moving, it is not changing its shape. But that's what liquids do. Liquids flow. The molecules are just near each other and they just flow together. Okay? So now that's a liquid. Now our next type of matter is a gas. G-A-S. All right. So in a gas, the molecules are everywhere. They're everywhere. They are not near each other at all, okay? And because they're not near each other, solids don't have their own shape. And I'm sorry, solids have their own shape, but gases don't have their own shape. And for example, I want to show you. So I'm going to light this candle. Go ahead and get it going. All right. So we have this candle lit here. And right now, and actually fire is a type of gas, but let me show you. I'm going to blow it out. Look at that smoke. Look at that. Look at that. It's just everywhere now. That's why the molecules and gases are everywhere. They don't have their own shape. They're just free. And that's what you see with the smoke here, okay? So like that smoke is a type of gas because the molecules are everywhere. Could they take the shape of its container? Probably so. If I was to enclose this, yes, that gas would stay inside. But again, the molecules are still everywhere. All right, so that's a gas. Next word we're going to discuss is evaporation. Evaporation. Okay, big word, I know. But if you've ever heard of the water cycle, this word may be familiar to you all. So evaporation happens when water or liquid turns into a gas. It has to be heated, meaning heat has to be added to that liquid, and then it's going to turn into a gas. Sometimes you may notice after it rains outside and then you see a puddle in the street, and then you may come back a few days later or the next day, you'll notice that that puddle is getting smaller and smaller. It's just disappearing, and now it's gone. Well, nobody didn't go and drink the puddle. But that water has evaporated. The heat in the atmosphere has made that water evaporate, and it turned into a gas. And that water has now gone up into the sky, up into the clouds. So that is evaporation, when heat is added to a liquid and it changes into a gas. Now, the opposite of evaporation. The opposite of evaporation is condensation. Condensation. Whew. Another long word. This is the opposite of evaporation. This is condensation. Condensation is when the gas changes into a liquid. Now, for evaporation, we had to add heat to the liquid to change to gas. But now condensation is the opposite. You're going to take heat away from the gas and turn it back into a liquid. For example, if you've ever had a cold drink and you set it outside, and when you went back to pick it up, you noticed that the outside of it was kind of wet. Did you think your drink spilled out of it? No, it did not. That's because the gas that's in the air, your cold drink is taking the heat away out of that gas in the air, and then that gas has changed back into a liquid and formed on the outside of your drink. So that is what condensation is. All right, so those are your vocabulary words for, like I said, we're going to be using that for this lesson and throughout the entire States of Matter unit. All right, so here we are in the lab. first thing you need to always remember before you do an experiment is first, always have an adult with you, okay? Next is you have to protect yourself. So as you see, I have my safety goggles. I also don't have on any jewelry. And my sleeves, I roll them up because I don't want any loose clothing. Also, it's important to wear gloves. However, for this experiment, we're making slime. You probably made slime millions of times, so you probably don't need any gloves. However, I will say to make sure you look at the ingredients of your of all of your materials and just make sure there's no ingredients inside of it that could harm your skin. And if it is, you would need to wear some gloves. But like I said, for this, I don't need gloves, but you may. So check your ingredients first. All right, so first thing you need is glue. And this is a 4-ounce bottle of glue. I'm just going to open it up and I'm going to pour it inside of my bowl. Gotta squeeze it out, squeeze it all out. I think it's almost out now. Almost out. Okay. Still a little bit more. I'm still gonna just kind of hold it. So while that little bit is still coming out, we're gonna go ahead and move on to food coloring. So if you want your slime to be a certain color, now is the time to add the food coloring. All right, I'm going to pour that. I don't want glue everywhere. All right. So now we got all the glue in. Now let's add some food coloring. I have some red and blue, and if you mix red and blue together, you'll have purple. So I want purple slime. I'm going to add some drops of the blue, about 5-6 drops, and about 5 to 6 drops of the red. Okay, and the coloring, it totally depends to you. If you want a lighter color, don't put so much food coloring. If you wanted a darker color, use more food coloring. All right, now next is you need baking soda. So you get a tablespoon, a half a tablespoon, and you get a half a tablespoon of baking soda. All right, so I have a half a teaspoon, and I'm going to sprinkle that all in my mixture. All right, next is the contact solution. You need a tablespoon again of the contact solution. So I'm going to fill up this spoon with the contact solution. All right, there we are, and I'm going to pour that in. Now, get a spoon and stir. All right, so I'm stirring up so you all can kind of see it. And it's turning that purple color because I mixed the red and the blue together. And now, here it is. It's getting slimy now. Ooh, look at that. Oh, look at that. Now, some of the coloring probably hasn't mixed well, but that's okay. Because I still see some streaks of red and some streaks of blue, but it's all right. If you feel like yours is way too sticky, you can add a little more contact solution to it. But if you think it's still a good consistency, then it's fine. All right, so now I have my slime. Look at that. Have my purple slime. So on your assignment, you're going to list some of the properties of slime. You're going to talk about how it looks. So look at the colors of mine. You see that it's kind of purple, bluish, reddish color. It also looks shiny. So that's another word to describe. It looks shiny. Also, it is translucent. We can't see through it. So it's translucent. All right. So those are some words that describe it. Also, we have Let's talk about smell. Let's see what it smells like. Don't really have a smell. Not really. So you could say that it has no smell, or it may smell like glue, probably, or it just has no smell. Mine doesn't have a smell. Let's talk about how it feels. Oh, let's see. It feels sticky. So that's one word to describe it. It's sticky. It's also soft. So you can also list that as well. Slime, yeah, kind of sticky and soft. All right, and taste. We know we can't taste slime. This isn't an edible slime, so we can't taste it. Hearing. Well, it makes a little popping noise if you mash it together. Sometimes there's a little bubbles inside of it, and those bubbles are popping. There's a little bubble here. Oh, it's gone now. But if you squeeze it, it makes a few little popping sounds. So it makes a small popping sound. You can add that. All right. And then the last question on your document, on your assignment, it asks, do you think that slime is a solid, a liquid, or a gas? And you have to explain your answer. So explain. What do you think this is? Is it a solid, a liquid, or a gas? You're going to add that answer to your assignment. All right, so that's our slime experiment where we have discussed the properties of slime. Let's get ready to learn about the 3 states of matter. Yeah. The 3 states of matter are solid, liquid, gas. Solid, liquid, gas. Solid, liquid, gas. The 3 states of matter are solid, liquid, gas. All day long. The floor is a solid. You can jump up and down. Jump up and down. Jump up and down. The floor is a solid. You can jump up and down all day long. Water is a liquid. You can drink right down. Drink right down. Drink right down. Water is a liquid. You can drink right down all day long. Air is a gas. You can breathe right in. Breathe right in. Breathe right in. Air is a gas. You can breathe right in all day long. The 3 states of matter are solid, liquid, gas. Solid, liquid, gas. Solid, liquid, gas. The 3 states of matter are solid, liquid, gas all day long. All right, it's time to eat some matter and drink some matter. We'll see you next time.